right. Welcome to Forward Future Live today, August 15th, 2025. And we have a very special episode for you today. Backed by popular demand, we're going to do something special and we're going to have Hiten Shah on as a co-host. Welcome, Hiten.
Glad to be here.
Yeah, man. I'm really excited to do this episode with you today. So it's been quite the week in AI. It's been almost or just over a week since GPT-5 launched, dominated the benchmarks, but also very mixed user reactions. So we're going to cover that. We're going to talk about Nvidia and AMD's new chip deal with the Trump administration and the new normal of negative margin businesses, but maybe not so new. We'll get into that. And we have three fantastic guests today. We have Jordan Nanos from Semi Analysis to talk all about chips, semiconductor industry, and everything related. We have Tejal Patwardhan from OpenAI to talk about benchmarks. She leads the benchmarks and evals team over there. And Guy Gurari, co-founder of Augment Code. And as always, we'll be starting with some speed running of the news. And let's get right into it. How does that sound, Hiten?
Yeah, let's do it. Really exciting lineup.
All right. Well, let's start with GPT-5. So GPT-5 launched, it seems like a long time ago, but it was just over a week ago. Really came out of the gates hot, dominated the benchmarks, but quickly got some pretty, let's just say, mixed reviews. I got a lot of negative comments on my videos because I tested it and I loved it, but a lot of people did not have the same experience. So first, what was your initial experience and what has it been like in the subsequent weeks since launch?
Yeah, I think my experience is that it felt like it completely lost personality. And that I think has been said over and over again. And that's probably why folks were like, hey, where's my 4.0? Where's my 4.1? So watching that whole kind of thing happen was also just a fascinating learning, because I think we all should remember this is all new stuff. Like, this is completely new stuff. Like, nobody really knows what's going on here or what we're doing. We're just shipping these models and seeing how people react, which I kind of like it. So I would call GPT-5 the YOLO model, because I felt like they just YOLO'd it, shipped it, and obviously are going to see what happens. It feels like the first model they've done like that. And then in testing with the API, I have to add that, like, we figured out pretty quickly it seems to be routing to other models.
Yeah. It's interesting. I think OpenAI really underappreciated how attached people get to certain personalities of models, and that has a lot of consequences to it. One, if you're like, you have to assume they're updating these models frequently, whether it's kind of upgrading, excuse me, the weights, fine tuning, updating the system card, or I should say the system message. So they're always changing it, but this was obviously a drastic change, a completely new foundational model. And so it had, as you said, a very different personality, and people got very upset about it. They were very attached to that 4.0 personality. And then quickly after, OpenAI brought back 4.0. And so I think they learned a lot, but like, what do you think about the attachment of people to the personality of a model?
I've been thinking about this quite a bit, and I think it just boils down to the fact that we shoved the machine into a chat. We shoved the thing into a chat, and now we as humans are chatting with it like it's another human. And historically, all we've chatted with is other humans. Like, yeah, there were some bots and some support bots and stuff like that. So I'm almost thinking about this and looking back in hindsight and be like, what do we expect if this is the mode we're using? Of course, we're going to get attached to it, because that's what humans do to other humans when we chat with them, and they respond. So it feels human. I was going to say human-like, but I feel like it's even more than human-like at this point, judging by people's reactions.
Yeah, and there seems to be two reactions, or kind of two categories of reactors. One, the folks who are like really attached to the personality of 4.0, and then probably more akin to what I would be upset about is they have workflows that have been set up with 4.0 in mind, and it turns out you can't just swap in and out the model. I know Edwin from OpenAI just dropped an entire like prompt conversion guide, helping people understand, okay, if you're going to upgrade to GPT-5, here are all the changes you need to make to your prompts, because it's a very different model.
I laid this out in a post as well, and I felt like my usage is very input output driven. Like, yeah, there's conversational stuff and there's workflows, but my usage mimics what I'm seeing people are saying of how to use GPT-5. And so I was already using it in similar ways and using those tactics that I'm seeing come out with 4.0 or 4.1 or even Claude in the past. So in some ways, it feels like I think people are catching up to how to prompt, period, when it comes to these models. And GPT-5 is almost bringing that to become a more important thing. And that's kind of why I said I think it lost personality. I'm not sure if that's good or bad. That's usually a bunch of tweaks on the system prompt and obviously something to do with their training. But overall, like it really does feel like the positive side for me is it feels like we're learning how to use these things. And we're also learning how to make them provide us with the kind of outputs we want, less hallucinations and much more consistency with the outputs. Those are the things that I noticed GPT-5 seems to be a little better at, if not a lot better at.
Yeah, I mean, the hallucination reduction is significant. It's noticeable. And I honestly 4.0, I didn't get a ton, but now I get 0, which is great. Obviously, there's always going to be some with extended periods of use, but I think the other thing to think about is the benchmarks are like, especially math, science, coding benchmarks, these things are all getting saturated so quickly. And so, when we talk about the personality of the model, I don't know, there's not really a benchmark for that yet. We're going to have Tejal on later today from the evals team at OpenAI. So maybe we can ask her about that. How do you start measuring and benchmarking against the less tangible aspects of a model?
So at least the way that I've seen it done is you're essentially just prompting a scorer to score the outputs, and you can, just like with any other prompting, you can make that prompt. Yeah. So basically, the process that historically most people do is they'll do some level of manual evaling, right? And they'll do human scores, and we're obviously can do things more subjectively. So we can score it on things like, is it more conversational and all of that stuff. And then with those scores, you can actually create automated scoring, which is an LLM scoring every output. Right. So I just think that we've been so caught up in, we're getting to AGI, so these are the benchmarks, when we kind of missed this whole idea that these are humans talking to it, and humans might not be like today. I don't think every human talking to it is thinking about AGI. What they're thinking about is like, can I get what I want out of it, whether it's just a conversation, a feel good thing, or actually some output. So I just think we're learning how we want to use these things. And there's a big chunk of usage we didn't account for with the benchmarking.
Yeah, totally. There's like the raw intelligence of the model, which is like the math benchmarks, the science benchmarks. And then there's kind of the personality, the tone, the length of responses, all of these less tangible aspects. The SweBench team did say if an LLM can do it, we can test it, but we'll get to that with Tejal. Let me move on to the next topic. Nvidia and AMD agree to hand over 15% of advanced chip revenue to US for China export licenses. So that was the first story. And then almost immediately after that, China's government, the CCP, told their tech companies, okay, stop buying US chips. There are security concerns there. We're going to talk about that with Jordan, but I wanted to get your initial thoughts.
My first reaction was, this feels like classic deal making, because one thing that was mentioned in the announcement is they started the negotiations at 20%. So just want to just sort of put the asterisk on it and just say, hey, this is just deal making. And so I think these companies, these US companies, were given a choice. You either make a deal with us and take this fee, or you decide that you don't want that business. But who doesn't want that business if it's going to result in revenue? So it was almost like a, win-win.
Yeah, there's so much money to be had selling chips to China, obviously. So you're 100% right about that, and it does feel like Trump tactic 101 here. Like just ask for a ton and then negotiate back when it makes sense. It's just interesting. And then what do you think about China saying, okay, stop buying chips? Is that truly a security concern, or do you think that's more we really need to invest in our own chip architecture and infrastructure?
I think they already are, but I think Huawei, I always forget how to say
Huawei.
that. Huawei, there you go. I
Yeah,
figured you'd
yeah.
know. They came out and said we can't use our chips. We have to go use Nvidia chips. I don't know if you saw that, but that came out right after. So in some ways, it's like the deal is with US companies, but then the deal is also with China. And so there's just like a 3-4-way thing going on here. And so I think it's geopolitical at this point. And I know we're going to talk a little bit more about that from that standpoint, but that's all I could think of.
Yeah.
Right. There's something going on here that people are optimizing for that the general public probably is not going to be fully aware of.
Yeah. Okay. Well, since we're on this topic, let's bring in the expert. We have Jordan Nanos from Semi Analysis. I've spoken to Dylan Patel. They're just a great group of researchers and analysts talking about everything semiconductor industry. So, Jordan, come on the show. Welcome.
Hey guys, great to be here.
Yeah, good to see you again, buddy. All right, so first let's take a step back. Jordan, tell us what you do at Semi Analysis and just briefly what Semi Analysis does.
Yeah, so at Semi Analysis, I'm a member of the technical staff. I work on the AI engineering team. Right now, I'm working on a project called ClusterMax primarily, which means that I'm meeting with all of the different neo clouds that install GPUs and rent them out to people, and I'm testing out the services that they offer and then writing up my findings. We're going to be publishing version 2 of that article pretty soon. Generally speaking, Semi Analysis has a big business. I think most people are familiar with the newsletter. Got over 200,000 subscribers who get those emails in their inbox, all sorts of things across the semiconductor supply chain, all the way up to AI. And then we've also got more of the institutional business where we sell consulting services and data products, as Dylan would say, expensive spreadsheets to some of the people in the semiconductor supply chain who want to learn more about accelerators, data centers, the wafer fab equipment model, things like that, or investors who are looking at the industry.
All right. Well, let's continue on the conversation Hiten and I were having. So, what is your take on China saying stop buying U.S. chips because of security concerns?
Yeah, I think it's interesting. Look, the China has a history of putting their finger on the scale for important industries through subsidies or through investment or through mandates. And this is clearly all three, right? So they're making a lot of investments in Huawei and Cambricon and other companies that are producing accelerators to compete with Nvidia. They're also working on the fab side with SMIC and other companies that kind of compete with TSMC. And now they're taking those accelerators of Huawei and they're going to the producers of AI models like Deepseek and saying, hey, you got to use the GPUs. I think it's interesting because, look, at the end of the day, what we've seen with all of these accelerators is you can make them work given enough time and enough effort. And it's about priorities. And so if the government is telling, a business that's got a for-profit arm and then a research arm, that this is the priority, you got to make it work on these chips rather than making the latest and greatest model. It could be a point for them to slow down right now, but it could cause some acceleration in the future if they can start to produce these at scale. So yeah, right now it seems to be holding Deepseek back. We haven't seen R2. We're excited for that. But it also may cause, Huawei to race forward in the future.
Yeah. So you say, or you believe, it was kind of a little bit rumored this week, Deepseek's delay is because China is forcing them to use Chinese chips. You think that's true?
Yeah, there was an article in the Financial Times on that. Look, the team at Deepseek has obviously had a pretty long track record of execution from like Deepseek V2 to 2.5 to 3, and then with R1 kind of all releasing on a cadence, all seemingly around Chinese holidays, which is nice. They seem to release and then go party. But, it's interesting, right? Typically when things are delayed, it doesn't mean that the model is really good. We've seen this from Frontier Labs across the board, right? We're expecting
not naming names, huh?
I can name some names. I mean,
that's all good.
On the floor for a while, it released. It was a little underwhelming. We've been expecting something called GPT5 for a while. I think they probably should have named O1 GPT5 instead of waiting to name this one GPT5. We can talk about some other stuff as well, but yeah, generally speaking, like I think waiting for bated breath for R2. I can't imagine it's going to live up to the hype, considering how much like the industry reacted to R1.
I wanted to ask you about something you said. So you mentioned that acceleration might come in the future.
Mm-hmm.
Do you have any estimation of timeline of that? So let's say they start working on making the chips from China work a lot better than the US chips. Like, what's the timeline?
Yeah, it's certainly measured in years. I don't know if it's 10 years at this point. I'd put it in the 5 to 10 year range for producing chips at scale. It's hard because I think there's all sorts of unknowns about restrictions that the US and other countries in the semiconductor supply chain can kind of put on equipment that currently China has access to. And it also kind of depends on continuing investment and attention from, in the form of subsidies or investments from the Chinese government. So yeah, I don't know what the actual timeline would be for producing, like for Huawei to produce chips at scale, but if everything stays as is with the current regulations and like export controls and stuff for the US, they can still get a lot of wafers from TSMC and they can still produce a lot of chips. Like we saw them release the 910B Ascend chip. They've released the 910C, which is what we believe, or what is reported is what Deepseek is using right now. But we've also heard rumors about the 910D coming. And, the point is that all of this is currently manufactured on a TSMC process. So if you're asking like how long until SMIC can overtake TSMC in terms of producing stuff, that's measured in like probably over 10 years. But if you're talking how quickly can they produce, chips that are close enough to be useful at scale at any power consumption or any investment dollar, doesn't have to be the best performance per dollar. You can see that in mobile phones right now. Huawei has no access to TSMC technology not TSMC, but other technology for producing mobile phone chips. And they can produce something that's excellent, that competes in the consumer devices directly with Apple. So, yeah.
Yeah, I just wanted to see how long the bulls have on Nvidia. That's all. Just kidding.
I don't. Yeah, if you want me to make the bull case for Nvidia, I think generally speaking, this whole industry is going to continue to grow. We're pretty confident in that, or I'm certainly pretty confident in that. And it's, I think it's unlikely it's going to be a winner take all dynamic for producing chips for AI into the future.
Yeah, and Jordan, did you see there was like a meme going around this week where it's 100 million ARR and then pull the mask back and no, it's actually $120 million Anthropic bill. And then I think like ultimately, where does that Anthropic bill go? So it's $5 from the user to whatever coding agent system you're using. Then from that $5, it's $7 to Anthropic. Then $7 is $9 to really Nvidia or hyperscaler. So tell me, like, did you see that? What do you think?
Yeah, I saw some of that. I mean, I think I've come at this from two angles. One is like we can sit there and criticize the gross margins of venture-backed businesses for as long as you guys want to stay on the live stream here. But I think that just speaking as a user of products like Cursor and Windsurf and Claude Code and GitHub Copilot and like on and on down the list, like I just don't know how they turn the clock back on this stuff. It's so useful for me and everybody I know in our day job that sure, maybe the economics need to change a little bit, but in terms of actually like the usage of the product, there's no way in which this can be a fad that we just wrench out of people's hands and say, no, you can't use your coding assistant anymore.
Yeah, and by the way, this isn't the first time we've seen VC subsidized apps businesses. Like you and I were right in the middle of it while we were getting $3 Uber trips across San Francisco. Yeah. That is not feasible as a business unless there's VC dollars backed by it, right?
I mean, there's so many angles here, but like, what about the 100x on your ARR when you're just a SaaS tool, no AI, right? There was a time when that was happening, not too long ago. So this is just a cycle, and we're all hoping it doesn't blow up in our faces, and we kind of create the value prior to that. That's the whole race, right? Like fund things, subsidize them, build the technology, and then not hope and pray, but literally hope and pray that execution meets demand meets execution, I guess, at investment.
It doesn't always work, but we have a bunch of examples of where it did. DoorDash, Uber, Lyft, right? There, I mean, I can probably name more, but there are tons of examples where it was just kind of saturate the market as quickly as you can, capture the market as quickly as you can, and here's all the dollars to do so. So it does seem like from the application layer, it seems like that's happening again. What do you think, Jordan?
Yeah, I mean, I think there's lots of ways that you could say businesses like that are huge and very important in the industry today were measured like this when they were starting out. Like, look at the biggest companies in the world: Amazon, Facebook. You know, these are Nvidia. These are companies that were venture backed. They lost money or had, you know, negative gross margin for a while, and revenue grew, and they were able to, you know, right size the business at the point at which they had enough revenue to justify doing that, or when they ran out of money and decided to do that. So yeah, I mean, at some point it seems obvious that there's companies being founded today that will be absolutely massive in the future. And if you look at the likes of Cursor and Windsurf, and I look at the day-to-day, you know, or Claude Code for sure with Anthropic as well. I mean, if you look at the day-to-day of what people are doing, it's just like you're saying, it seems hard to take this away and turn the clock back. Like, I really, the extra amount of friction to not have an app to order the Uber when I land at an airport and want to get in a car, compared to like flagging down a taxi in the past or trying to take public transit. Like, I mean, I can't imagine that, like, that experience is just not worth it to, in that case, a business traveler or something that I'm describing. So like, we're going to settle on a price that makes sense for the software engineers to pay for these models. And there's going to be a matching in terms of like the quality of the model that you get for the price you're willing to pay at the speed of the output. And, you know, and that'll work out. And until then, like, yeah, enjoy the VC dollars, enjoy those $3 rides.
Yeah. Okay, let's move to kind of the inference landscape right now. We have hyperscalers, Google Cloud, Azure, and then we have the neo cloud companies. Like, tell us your overview of what the landscape looks like, and then what are the most important differentiators amongst these companies right now?
Yeah, interesting. So there's like, okay, there's a huge landscape in terms of like people providing GPU compute, I think, at this point. And I think it's easiest to frame it in terms of who's the buyer. So the three big buyer personas that I've seen in terms of GPU compute are like the users who want a managed cluster, like they want to log into Kubernetes or Slurm and just run training jobs, or like build up a inference endpoint and then serve that out to people. Then second, there's people who are buying wholesale. Effectively, like, there's no orchestration, there's no support from the data center. They're basically just getting as many GPUs installed in the data center as they can, and then they're taking over from there. And then the third is more on the on-demand side, which is kind of like anything from a hobbyist developer to an individual at a business that's starting up to a small startup who wants things, you know, to spin up, spin down. And so the landscape that people kind of think about this and attribute to is like the big three or big four, which is like AWS, Azure, GCP, and Oracle. I think from our view, there's been a fifth one added, which is Coreweave. Like, they're running compute in the gigawatt scale. This is a whole bunch of GPUs with some large customers. They're now a public company. Like, this is a big player in the industry at this point. And then there's this long tail of, let's say, I mean, we're tracking over 130 companies that we call neo clouds that have emerged. These are former Bitcoin miners. These are sovereign investments. These are VC clusters. So they're investing in companies through the use of credits on their GPU cluster instead of actually giving them dollars in some cases, or both. And it's really fascinating because it's basically the only industry that I know of where there's 130 plus companies spread around the world that are basically doing the exact same thing at this scale. Like, they're all buying Nvidia GPUs. A few are buying AMD, but mostly Nvidia. They're all plugging them in a data center, and then they're renting them out by the hour. trying to get people to commit for 1, 3, 6 months at a time, maybe years. So it's, we're calling it the build out. Like the build out is happening. And I mean, I can go through all those details of like comparing one versus the other and what builds on top of it, but that's what's powering like people making these investments of converting former crypto mining facilities into a AI data center is kind of what's powering a lot of the end user applications that we're seeing right now.
It's an interesting trade-off right now too, because crypto is, ATH and yeah, I mean, obviously they're doing the math on their end. So it's, inference and kind of the long game, and then crypto right now is popping. So it's super interesting. So then, but like, let's talk about Coreweave. What is the differentiator? Why is Coreweave the public company? Why is Coreweave now a hyperscaler versus NeoCloud? Whatever the definitions are, you kind of elevated Coreweave amongst all of its peers. Why?
That's a good question. Yeah. I think at this point, it really depends on the user experience to understand that. So generally speaking, when you think about like the neoclouds versus hyperscalers, the dedicated AI focused neoclouds are giving end users a better experience than the hyperscalers. I think Oracle and Azure have probably done the most to adjust their clouds to be easier to use for like a startup, but it really doesn't compare to a CoreWeave, Crusoe, Nebius, Together, Lambda, any of these, bigger companies that have GPUs on demand. They're aggressive on pricing. They're like under $2 an hour for an H100 now. They set up a cluster for you. Something goes bump in the night on a Saturday. You send them a message on Slack and they're like sending you a Zoom link 5 minutes later, jump in and fix it. Like this is not quite the experience people have with AWS, where they're like, install the CLI and spin it up and like
have fun,
file a support ticket if something goes wrong and, things like that. So, I think if you compare those two experiences, CoreWeave has done a really good job of designing from the ground up. They've done a really good job of providing people support. They've developed quite a bit of software around it, which I can talk about. And I think they're kind of just the leader in that sort of innovation, where other neoclouds are copying them a little bit. But it's still early innings of this. We're still yet to see like when these big projects come to fruition. Like you saw announcements from OpenAI with Nscale in Norway. Like there's announcements about Crusoe building in Texas and Wisconsin. They're measuring these projects in gigawatts, right? That's billions of dollars of investment in these build outs. So it's I think it's early innings, and it's really hard to count, I think, Google Cloud out specifically, but also AWS, Oracle, Azure. Like they're all being very aggressive going for this market. I just think that they are. If I think about how I talk to the teams and evaluate what they're doing, a lot of them are kind of copying what CoreWeave has learned from working with the biggest customers, and then trying to go from there. And it's going to be this going forward. It's going to be this battle between like, can CoreWeave push out a bunch of new features and add a bunch of functionality that keeps people on the platform and lets them charge a premium, or are they going to get caught up and there's just only so much functionality that people really need out of a GPU cluster? Like, yeah.
Okay. And then talk about custom silicon. So I was up in Seattle yesterday interviewing the AWS CEO. That interview hopefully will come early next week. Obviously, by the way, thank you for the tip on Annapurna. I asked him about it. So yeah, I honestly hadn't heard of the company or the acquisition, and it turns out, yeah, he was like, oh yeah, we're super thankful that we got that one.
Mm-hmm.
But like, yeah, so he obviously talked about Trainium. He talked about some of their other custom silicon. Google has TPUs. How important is custom silicon in this race for infrastructure build out?
Yeah, I mean, it's huge. So it's really interesting. I think when we talk about custom silicon, we can talk about it in terms of the accelerators, or we can talk about it in terms of everything else: the CPU, the network, storage, how you boot servers. And I think right now it's easiest for people to think about the accelerators, but the discourse is in this world of like, what do people use for AI, is very much Nvidia versus AMD. We started out talking a little bit about Huawei. People are like, okay, maybe that's the third entrant into the market, something like that. But if I'm a user or if I'm a startup and I'm trying to decide where I run training or inference, to me, the pecking order is NVIDIA number 1, Google's TPU number 2, AWS Trainium number 3, AMD number 4, Huawei number 5, and then we got startups like Grok and Cerebras and Samanova that kind of keep the list going. So I don't think it's great to be comparing Intel Gaudi as well. Let's throw that name in there. There's a lot of chips that people can choose from. And so I think the biggest thing that we're waiting to see is whether Google goes and starts selling TPU externally at scale to big companies, right? We've seen announcements of them partnering with OpenAI. We think that's financing. We've seen them financing crypto, conversions of data centers to HPC AI. Like in TeraWulf's facility, they made an announcement yesterday. We've seen them. They've got a big investment in Anthropic. I think they own around 14% of Anthropic right now. Anthropic uses TPUs. So yeah, talking about silicon, like to me, it's about comparing from a user's perspective whether they're going to want to rent a Blackwell cluster or a TPU cluster, an Ironwood cluster, right? And that's a real decision for people to make, right? Like if you look at a startup like SSI with Ilya Sutskever, or you look at Thinking Machines or something like that, right? These companies raise $1 billion or something like that, and then they have a team of like less than 50 people. So they're clearly spending like 90% of the money on compute. Well, I mean, maybe they've got to retain these people right now, but I think they do that with equity, not with cash.
Yeah.
So like it's a really big decision to make, and whoever's got the best TCO in terms of like, performance, but also in terms of researcher productivity, it's really important. And it just seems like a huge business for GCP to be letting, go if they maintain their stance that they will not let anybody who buys TPU develop a product that competes with Google, which is like in the terms of GCP, user agreements and stuff like that. So yeah, anyway, we just think, SemiAnalysis, we're making a call that we think they're selling TPUs externally. Like they're going to be going for that market. And I think that's a much bigger thing for NVIDIA to contend with compared to AMD at this point.
Why would they make the decision to do that? Is it there's a greater margin there? Is it like it's just a new line of revenue for them?
Well, I think the approach that I've seen from both Google and Microsoft at this point, from Sundar and Satya, is that they're defensive when it comes to AI. So if this changes everything, we don't want to be left behind. And I think selling TPUs gives them access to a whole bunch of, partnership opportunities. They get a piece of the pie. The people who make the case that it's better to sell picks and shovels in the gold rush. TPU is the pick or the shovel, whatever, or the jeans, whoever got rich in the gold rush. I think that's a simple.
You had mentioned that Anthropic uses Google's TPUs, right, through their partnership. So
well, it's our understanding that Anthropic is basically sourcing from multiple different clouds.
Right.
Both OpenAI, Anthropic, XAI, Meta,
obviously AWS.
Google, they're just doing everything they can to get compute right now.
Yeah. So what I'm thinking is they're already selling it.
Yeah.
They're just selling it as part of these deals. So I don't think it's unreasonable to think they're going to sell it to the public or whatever public, or make it more available if they have the capacity. I'm actually curious about your take, if you have a take on this, on capacity.
Yeah. Like
because of all these build outs, like we're saying, hey, they might sell it, but do they even have the capacity? Do they have enough to sell to external parties based on the partnerships they already have, plus themselves and what they need, because they need it.
All right. So one of the guys at SemiAnalysis, Jeremy, just came up with this great thing for when we build slides where he puts source and then he puts sales@semianalysis.com. And if you click it, it starts an email. So you can send one of our sales guys a message to buy the accelerator model or the data center industry model. So if you're an investor watching this, like, and you want to think about what we think about those details, yeah, we're getting to the edges of what I understand about semi-analysis business, and like internally we kind of firewall off the work that I do on testing clouds compared to like the work that those guys do about tracking shipments and stuff. But I'm making this statement here because of what those guys are telling me, and they're tracking shipments and seeing everybody ramp up production, including Google.
Yeah, got it.
Yeah.
Okay, so then as you're thinking about capacity in general, I just want to continue on that just for a second. I know you have some proprietary stuff, but like are the application companies getting what they need? Is the demand far exceeding the supply currently, just from like the highest level perspective?
Everything I've seen from OpenAI, from Anthropic, from XAI, Grok, like it's just these charts that show these hockey sticks curves of how many people are using it, and all of these people who develop models who are like upset that they can't roll out the latest and greatest to all the free users that they have on the platform. Like you guys started out talking about GPT-5 and how OpenAI is thinking about rolling that out to users, and we wrote an article recently. Doug O'Loughlin, our president, kind of led the writing and basically describing GPT-5, the real release being the router, and how this basically sets the stage.
I read that. It was fantastic.
The free users on the platform. So
yeah,
I think as far as we know, basically demand exceeds supply by a lot. And then kind of, as I said previously, it's a matter of matching like the right user to the right model with the right query at the right time, and then monetizing it as needed, either through like having them pay per token on the API, or monetizing it some other way, which we believe is not necessarily a pop-up clickable ad like people might be seeing on YouTube right now, but some sort of more intention-based advertising where, depending on what the person is asking the chatbot about, referral links and things like that can be very valuable for a very like cheap query in terms of how expensive it is to compute.
All right, Jordan, I want to thank you so much for your time today. This has been awesome. Check out Jordan at semianalysis.com. We'll drop semi-analysis in the chat, also in the description. Jordan, where do they find you on Twitter?
Yeah, Jordan Nanos.
Jordan Nanos.
Yeah, Twitter.
It's in the chat now. All right, Jordan, thanks so much for joining us.
Okay,
Thank you.
Thanks, guys. Great to be here.
All right, Hiten, we got a few things to talk about now. From let's see, let me pull it up. We're going to be talking about a few things from the feed. So I think the first thing I wanted to talk about is this Wall Street Journal article that was published about, let me share my screen. Give me 1 second. All right. So Perplexity makes a long shot $34.5 billion offer for Chrome. This is a marketing play, right? I mean, I have to assume it is. This is the Wall Street Journal reporting it, but they don't have that kind of money. How would that even work?
I think the claim is that VCs, venture capitalists, probably private equity, I would imagine at these numbers, or VCs that are private equity, are willing to back it. So they've said that, hey, we have the money. So let's assume they have the money, because they said they have the money. Even in the story, I think it said that. I think it's a stunt, and I think this company's just good at stunting. Like they're just good at it. Like they've done this over and over again. In the beginning, it was a little bit cringe. Now it's getting to be maybe cringe is in. Some people have that to say. This is kind of cringe, but it's in, and it got them the Wall Street Journal article.
Yeah, cringe is in. There's one company that comes to mind when you say that. Cluely, I have to say. I mean, look. Whatever they're doing, they're getting the distribution, they're getting the views. So fine, I guess that's one way to play it. But okay, so back to Perplexity. Let's game it out. If they did, if Google was like, sure, we're going to give up this incredible IP, this incredible property piece of software, and Perplexity acquired it. They just built out their own browser, which is a fork on Chromium. Like, what do you think this is good for their business if they're actually able to execute this?
I mean, their browser is just fine. It's very similar to what they usually do, which is put something out that in the beginning they'd put stuff out that was not very good. Now they're putting stuff out that's a little bit better, if not a lot better than their initial releases of things. And then, over time they'll iterate it and all that. And we all know that as you get the data, you can make these products better because they're very AI first. I want to entertain what you're saying, but I think this might have just been a big ad or a way to promote their own browser in some ways, more so than trying to think that this is a serious thing. Because in reality, if Chrome was sold to them, would they know what to do with it the way Google does? And this means that Google is going to be forced. Google would have to be forced to sell it to someone. And so,
They
and then
almost
there's all
were.
the antitrust stuff.
Yeah.
So.
Yeah. I mean, they almost were. But like, let's think about the browser as a major surface area for interacting with artificial intelligence. I think for me, from that lens, it does make a lot of sense. I think it made a lot of sense for them to build their own browser. And in fact, I use it just because it was so easy to migrate to it. And it just has all these additional features. Sometimes I use them, sometimes I don't. But ultimately, it was like a one-click transfer. And now they, obviously I'm kind of testing all these new products, and my mom is likely not going to be using Comet anytime soon. But she does use Perplexity, actually, I should mention, all the time to prove me wrong about stuff, funnily enough. She sends me links like, hey, you were wrong about that thing. But yeah, I know. But I'm thinking, like, from a strategic point of view, building the browser and capturing the browser, they're trying to prevent what happened to Facebook with mobile, right? They want to be controlling the surface area that people interact with artificial intelligence on. So what do you think about that as like a strategic decision? And is the browser kind of the ultimate interface between humans and AI?
I think the browser is commoditized now. Because if Comet can come out, Arc turns into Dia, and there's a number of other ones, isn't it just a desktop app that has access to the internet and can help you get to websites? Like, I know I'm really marginalizing what these products are, but we call it a browser. But when you play with Dia or you play with Comet, you even play with Chrome and some of their AI features, it's kind of like the website is just context, or the websites are just context, and the browser is used to browse like a human, right? And do automations or all of those kinds of things. So I would actually say that I think browsers are commoditized. We're probably going to see more and more things that resemble a browser that don't really feel like a browser maybe. And as we get into that world, Chrome becomes less important. So part of this is just almost like, that old school Craigslist and the unbundling of Craigslist.
Yeah.
In some ways, this is like the unbundling of Chrome.
Oh, interesting.
And that's the way I would start thinking about this. And yes, Perplexity and the browser company have built full-on generalized browsers. So what I'm thinking about, even to be frank, in some of my own businesses is like, wait, is a desktop app just a browser? If so, are we going to have specialized browsers for different use cases? Or browsers, I'll put in quotes.
Yeah. And then, okay, so then let's assume the browser is getting commoditized. Let's assume kind of the software side, the application side of things is getting commoditized. What do you think is the ultimate platform to own in this AI future? So as OpenAI is thinking about building out their own hardware, Google has Android, they have the Pixel phones, Apple obviously has theirs, although we'll see what happens with their AI approach there. But like, what is it? Is it a device? Is it a phone? Is it something else? What do you think?
I think it's the operating system. I think the real fight, so to speak, or war, is for the operating system. And that operating, and even Perplexity, I think, has come out and said, we're going to build an operating system. They come out and say they're doing everything. So that shouldn't be a shock to anyone.
Didn't they buy OS.ai?
I think they did from Dharmesh Shah, actually, if I recall correctly. He's been hoarding a lot of these domains. Good on him. But he's giving them up. So that's awesome. But like, I just look at this and I'm like, oh, the operating system is the key. I would bet on Apple over anyone else there once they get their act together, or once they see things working and do what they do. Because we keep forgetting about them because we want amazing products from Apple. But Apple builds amazing products when they've had enough data about a market, a product category, so they can go do it better. And a lot of these categories, we don't have enough data. VR, AR is a great example of us not having enough data. And when I say data, I mean not the traditional data, but like how consumers are using these things, where these things are failing consumers. So I wouldn't write Apple out of this yet, because they own the OS that's more closer to the metal, so to speak. They make their own chips. The chips are very powerful. We can do local models on them very easily. Same with our phones. So as I keep thinking about this, to answer your question, and you might have said this at some point as well, I think it's the operating system, not the apps. And we need to hook into those with our apps.
Yeah, I tend to agree. Definitely don't count Apple out. This wouldn't be the first time where they were following other innovators, right? They were not the first smartphone. They weren't the first a lot of things. And then they came in and did the Apple way. I think the difference this time is they actually did launch Apple Intelligence, and it was more than a flop, right? It was just I've never used any product less than that. Siri got worse somehow. And so, but yeah, look, they have all the money in the world. They have the operating system. They have billions of users. I'm certainly not counting them out, but it does feel a little bit different.
Do you know how Microsoft gets better at product?
Tell me.
They ship a product. It's pretty crappy. And then they just go after every single use case, every single feature. And like, for example, if you look at OneDrive and all the releases for OneDrive and how it started competing with Google Drive and Dropbox and other companies like that, like, it's incredible how far out that product is for certain use cases for their customers. And the reason I'm mentioning them is I think we're in a world where Apple has to do that model and has to learn how to do that, which is ship and iterate instead of ship the perfect thing as a first version that they can iterate from. And that's the struggle at Apple that I see. And this was triggered to me in my head when you said Apple Intelligence was launched. I'm like, yeah, you're absolutely correct. It was launched, but the market wasn't mature and they launched it. So they didn't have any data, they didn't have any user behavior to say, we can do this better. That being said, if you play with the writing tools for Apple Intelligence, they're very good.
Really? I have not used it at all.
Because it's hard to dig in and even know that you should be using it and all that. But like, yes, they're very good and they're very smart and they're best in class from what I could tell.
Yeah, it's funny because I've been an Apple user. Like, that's my main computer.
I was going to say fanboy, but
okay, fine.
Sorry.
Fair. No, it's true. It's true. I've been an Apple fanboy. However, I have a Google Pixel now, and I bought this because I was like, hey, I want the latest features. I know Google seems way ahead in terms of integrating their AI capabilities into Android versus iOS. So I'm waiting. Like, I want to see them do well. I'm not rooting against them. I like Apple. I want to continue, as you say, a fanboy. I want to continue seeing them succeed. Android user. All right, Alex, thanks for that. So yeah, I want to see them succeed, and I guess we'll see what happens. All right, so I want to bring on our next guest. I'm really excited for her to join us right now, Hiten. This is Tejal Padwarden. This is OpenAI's member of the technical staff. She's been leading a lot of their evals. She's written a few papers that I've made videos about, which are awesome. We're going to talk all about evals and safety concerns and GPT-5. And let's bring her on. Tejal, welcome to the show.
Hey guys, thanks so much for having me.
Yeah, good to see you again.
Good to see you again too.
Okay, so let's start with the basics. So for those who might not be familiar, what a head of evals, member of the technical staff at OpenAI actually does on a day-to-day basis, share a little bit of context about that, please.
Yeah, so I work on evals here, and the goal of a model evaluation is to really understand what our models can do. So what is their knowledge like? What are their skills like? What tools can they use? What are their behaviors? And we try to do this in a way that's very quantitative and measured rather than being vibes-based. So we'll build a lot of different benchmarks. We'll port benchmarks that are published externally and use them to sort of measure how well our models are doing towards AGI. And then all of these metrics and results are used to help make decisions on research, on safety, on launches, and really try to steer our research direction and our product direction towards something that's beneficial.
Okay. And so you think about benchmarks a lot. I came into your office a couple months ago and we were chatting about some of the papers that you co-authored, and we're going to get to that in a moment. But I want to start with benchmark saturation. Like with GPT-5 just annihilated a bunch of benchmarks, right? AMD 2025, some of the science benchmarks, some of the math, you're getting gold at the, I forget the competition, but
IMO, yes.
That's right. Yeah. So as you're thinking about how to differentiate benchmarks, like what are some of these benchmarks that aren't just like, hey, are you good at math? Are you good at science? Maybe less tangible aspects, less tangible qualities of a model. How do you start testing for those?
Yeah, I mean, in some ways, the model smashing through the benchmarks is a testament towards really fast research progress. And so in some ways, we should be very proud of that. But in terms of other ways that we should measure our models, increasingly, we're moving away from very self-contained or academic style benchmarks. Like we used to give the models the SAT or the LSAT, and now the models are really good at acing those kinds of artificial self-contained tests, and moving more and more towards very realistic, very open-ended, very complex, very long horizon settings that are more similar to how long horizon work in the real world would actually work.
And like when you're, so you had a couple interesting papers. There was Sweelancer, which you were a co-author on, and it's basically, can you give AI the ability to actually go earn money in the real world from freelance software engineering? And then there was Paperbench, so evaluating what AI's ability to actually replicate AI research. And these are very tangible real world benchmarks. Is that where you and your team are headed, to the more real world applicable, maybe revenue generating benchmarks?
Yeah, we're definitely trying to move towards more realistic and complex, relevant benchmarks. I would say we were very excited when you made those videos because you were like, oh, people are looking at the right things. For Sweelancer, it was really exciting because we really care about our evals being interpretable. And so sometimes when you see the model gets X% on X random academic benchmark, it's very unclear how that helps people in the real world.
Yeah.
And the thing about Sweelancer is it actually measures the amount of money that someone would have made as a software freelancer in real front-end engineering tasks. And so that helps, giving it a dollar amount helps interpret, okay, here's sort of the scope and the size of work that the models are able to actually complete. Similarly, for Paperbench, one of the first things you do when you join as a researcher, or if you're an early researcher, is you're just re-implementing existing papers to become familiar with the methodology, find issues, make sure that you can sort of have a stack to build off of. And being able to see if our models can do that is really laying the groundwork for, can our models help accelerate the pace of research into alignment or safety or robustness or model progress? And so building these evals that are actually helping us do the kinds of work we want our models to help with is sort of how we pave the way towards making progress.
So there's a bunch of. Oh no, go ahead.
No. So I was going to ask specifically about Sweelancer because I was so fascinated by that paper. When you were going through it, were you like, oh, we're basically giving people a blueprint to go earn like this arbitrage opportunity?
We thought about that.
And?
I mean, I think it's probably empirically true that if you are someone completing freelance tasks with the help of a model versus not with a model, you'll probably be accelerated by the model. But I leave that to the reader.
What I was going to ask about, and this could be a loaded question, but how do you choose those use cases? So you had mentioned, hey, this is what people are going to do with models and we want to test against that, right? How do you choose those? Because I'm really fascinated by the example. So curious how you chose that one and how you folks think about choosing what to go after.
Yeah, I would say there's sort of two ways to go about it. So one is you could have a pretty opinionated approach of here's a set of areas we definitely want our models to be better at, and we should make sure we have good coverage in them. So for example, coding is one of them, science, other real world work that you might pick. But then on the other hand, we don't care about making sort of just a specialized model per se. We care about our models making generalizable progress that's very scalable. I mean, one of the really exciting things about the IMO model was that the same model that did really well on IMO, which is a math competition, did really well on IOI, which is a programming competition. And we're interested in seeing, can we teach our model skills in ways that generalize across a diverse range of domains? So in that sense, we're sort of not opinionated. We want to include as many different domains and skill sets and knowledge types as possible and make sure that we're making smooth progress through scaling.
And Tejal, Hiten and I were talking about the GPT-5 rollout earlier, and like this realization that a lot of people got very attached to 4.0's personality, and like in some ways I understand that. What kind of benchmarks can you do for less tangible aspects of a model, like personality and tone? Like what does that flow look like to make sure, hey, we understand what the personality of this model is going to be?
Yeah, measuring personality is very complicated, and full transparency, I work more on the frontier evals capability side, less so on the model behavior side. But some of the things that we've done include looking at creating sort of systematic evaluations for this type of model behavior. So for example, we have the spec and we sort of have laid out, here's how we want the model to behave. You can construct a set of prompts that relate to each part of that spec and then measure how the model does when repeatedly sampled or sampled in different settings, and then sort of score how does that shift over time with a set of graders. We also have, A/B tests that we can use to sort of measure how things feedback's incorporated in human evals. And then finally, there's the good old vibe check, which is have a bunch of researchers play with the model and see, does this feel right? Does this feel like the kind of behavior that we want to put out into the world? And I think a combination of those things can sort of help steer towards the kinds of behaviors and traits that we want to see in our models.
What's your vibe test, Tejal? What are you doing?
Vibes are good right now, but I mean, I can see more than is published externally, so.
No, but like what tests are like when you first get a version of the model, what are you typing to it? What are you actually prompting it with to say, like, does this feel right?
So I would say compared to some other people that might go straight towards like a vibe base, like write me a story. I do have a tell me a joke, and often the joke is not as original as I'd like it to be. I actually care more about the evals. So I'm like always on our dashboard of like, oh my gosh, how's the latest run doing? Like which evals is it spiking on, looking into problems that it's failing and finding the failure modes and skill sets. So I'm very much more into like the larger scale plots and like evals than I am any particular prompt, because I care about overall generalization and scaling.
Okay, and I want to talk a little bit more about Paperbench. That was a really exciting paper to read because you kind of saw hints of a model being able to really do self-research and potentially even update and improve itself. I know that wasn't necessarily the point of the paper, but it kind of hints in that direction. So as you were doing the research for that paper, what were you thinking in terms of like, does this lead towards self-improving AI?
Yeah, your video on it was shared around in our Slack. I think we talked about this when you visited the office, but you did a really good like line by line highlighting of every single piece in the paper. So that was exciting to see. In terms of the goals of the paper, I definitely think that it's part of measuring progress towards self-improvement. And that's something that's both exciting and something we should be cautious about and make sure we're measuring the progress of. But if models are able to replicate research papers, that's just one of the first building blocks towards being able to understand problems in existing research papers and then maybe propose novel research ideas and make progress actually in machine learning research directly. So that's the right kind of question.
So what I'm really curious about with that research in particular is what surprised you of it? Like, was there anything surprising that came out of it? Because that's like I think one of the most, I'm sure you'd agree, but one of the most interesting kind of feedback loops that we have with AI. That's why I was just curious if anything surprised you.
What surprised me might be different from what you think I'm going to. What surprised me is that so to make this possible, we actually worked with the co-authors of these papers because we wanted to make sure that measuring the model on these papers was accurate. So we had them help develop these rubrics with us, and more hearing from them, like their excitement to be part of this, to be like, wow, it'd be really cool if this could be accelerated by a model so I wouldn't have to do the tedious parts of research that are less fun. I think I was a little bit surprised by how excited people were to work with us on a project making rubrics of their own papers. So that was personally surprising. In terms of seeing the model's progress, I think there hasn't been anything that's sort of different from other benchmarks, in the sense of it tends to be the case that once we make a benchmark and we set it as a goal to measure progress towards it, the progress occurs.
Yeah, that's so interesting. Of course, like if you can't improve unless you're measuring something, right? And it's almost like the opposite as well. You're not going to start making progress unless you start measuring it to begin with. Um, okay, so I want to talk about you did some research on emergent misalignment. And I want to talk about that for a minute. So it's basically a model develops negative features from data noise, and then you can fix it with quite a limited sample size. So talk a little bit about your research there, and we'll get into that.
Yeah, that's one of my favorite papers that I think was a little maybe like not as hyped or like as well spread as maybe it could have been. It was a big team effort. There were a lot of people on interrupt safety systems, reasoning that worked on this. But the idea of emergent misalignment is throughout the course of training, your model might develop some features that lead it to adopt a persona that you don't want it to. For example, we have a bad boy persona that the model can adopt if there's certain training data that sort of skews it. But what we found, and this is building on the work also of Owain Evans and his group that had found some of this behavior earlier. But what we found that I thought was really exciting is that you can actually measure and catch this early. So not only can you sort of build evaluations that sort of track this behavior, you can even look deeper into the model internals and find in the latents of the model, oh, this bad boy persona is emerging, and find that before it's even visible in the output. So even before it would show up in the outputs, you can catch this through the latents. And once you catch it, you can also train it away in a very data efficient way with a very low number of samples. You can sort of, in reinforcement learning, train that behavior out and make the model realigned, which to me was very exciting because, you know, with these behaviors like sycophancy or other model behaviors that we don't want, this is this new way to actually, during training, catch them as they occur, even before we can find them in the outputs and then steer them away, which is very optimistic to me and very exciting.
Yeah, and okay, so you talked about catching it in the latents. Did you happen to read that? I'm sure you did. The Anthropic paper where they really went deep into how the models think, and it's kind of surprising they don't think a lot of the ways we thought they think, and they have a universal thinking language that isn't necessarily natural language. First of all, did you happen to see that?
There's a few papers on this, right? I'm not sure which one specifically.
Okay, so but generally, okay, so we're just starting to scratch the surface of understanding how the models think internally. How can you catch some of this behavior early if we don't even know how the models are thinking about it?
Yeah, I mean, interpretability is very complicated and hard as a problem, but I think there's certain well-defined pieces of it that we've been making progress on. So one of them is identifying these latents that we did in our paper. And another is, you know, this chain of thought monitorability stuff that we've been talking about, where when models reason, they have this chain of thought and you can sort of monitor that, and the models will often tell you their behaviors in that chain of thought. And so I think if you have these sort of well-defined research problems where there's a specific sort of behavior you want to monitor or a specific aspect of the model that you want to keep tabs on, you can sort of use that to make progress. So I'm excited about those smaller projects, but the overall goal should really be, can we understand what our models can do and what they're thinking, even if it doesn't show up in the output? And that's a very important research challenge that a lot of folks across like interp, reasoning, other labs are working on, and it's important to work on.
Yeah, and I think around maybe in that same paper, maybe it was a paper around that time, but they basically showed that what the chain of thought actually says is not necessarily what the model is thinking internally in its latent. So like again, I'm going to keep pushing on this topic. How do we know for sure when we're trying to measure something when we don't even know for sure it's telling us the truth or really exposing what it's thinking internally?
This is a very important issue. So there's things we can do to make the problem of chain of thought faithfulness better. One is to not train on your chain of thought. So you can imagine if you train directly on chains of thought, or even if you're aggressively choosing which checkpoints should proceed based on whether you like the chain of thought, it sort of could have this evolutionary effect where the models that make it are the ones that are hiding what they're really thinking. And so one thing that's been really nice, and we put out a position paper on this, is if you don't train on the chain of thought, you're more likely to see faithfulness in it. But at the same time, you can't know for sure. And so there are some things you can do to try to make it more faithful, but there's a lot more work to be done to be sure. I mean, these are probabilistic models and nothing is deterministic here. And so everything really is sort of a best attempt so far.
All right. So I spoke to the SweBench team, I think it was last week, and they said, if a model can do it, we can make a benchmark for it. And so the context for that was I was asking a similar question to what I asked you earlier, which is how do you start benchmarking and evaluating against the less tangible aspects of a model? Like, obviously it can be really good at math, it can be really good at science, but I hate to use the word again, but it's like vibe. How do you test against this vibe? So do you agree, first of all, if a model can do it, we can make a benchmark for it?
I don't know if I agree. I think making benchmarks is hard. But so let's look at the example of creative writing, for example. I would ask you, can you tell which pieces of creative writing you like more than others? Like, do you think you have a heuristic?
That's a fantastic. So I think some people would answer yes. For me, probably. I think I like generally have a sense like, oh, this sounds pretty good. It's interesting or not. But outside of that, I don't know what's good versus great.
And I'm in the yes camp. I can tell. Just putting it out there.
How can you tell?
Vibes. No, just kidding. It's more. I'll tell you how I tell. Usually, again, I'm trying to explain something that's sort of subconscious to some extent. But overall, if I were to try to quantify what I'm doing, I'm just trying to figure out, is this going to work for the audience it's intended for, and at what scale? Like, is it like a C? Is it a B? Is it an A? Like, I'm essentially doing an eval on it if you want to look at it like that. But I'm doing it against something that I believe about any piece of content or any comms, which is there's an intended audience. So I do start with who's the intended audience, and then I can do that judgment fairly easily.
Yeah, so I think there's basically two approaches, right? One is if you have a set of problems that are objective, like, it's easiest with math, some types of math problems where there's a verifiable correct solution, and you should just build benchmarks with verifiable correct solutions. And then there's more subjective capabilities that we might want to measure where the correct answer might depend on the person. Like the two of you had different, interpretations of what good creative writing might look like. And if you were different users of ChatGPT, what you want as an output might be different. And so in these cases, a lot more personalization based, evaluation or human evaluation is necessary, but you can still turn those into scientific or like more rigorous measurements. For example, we've published a bunch of human evaluations before where you just randomly assign groups of people to different models or let the same person see multiple types of models and let them pick which one is better. And that's a way you can sort of quantify the vibes. So even though there's a difference between sort of objective and subjective measurement, you can still ultimately run experiments on both and try to get some insights.
Yeah, Heaton, that was super interesting to think about it as like, who's the target audience for this first? And then like in that scenario, you can set up, obviously very difficult, but you can set up this feedback loop like, okay, serve that content to the audience, get their reaction to it, whatever it is, time on site, engagement. And that's like, unless you own end-to-end the platform, like OpenAI does, you can't really do that. But I guess, Tejal, that's what you're saying. Like, hey, we can serve different content to different audiences, see how they engage with it. What does that actually look like?
So memory and personalization is something we've been working on for a while, but different people have different preferences, and sort of making sure that you make the users get the experience that they want is a goal of ours. Like one example is emojis, right? Like some people really like seeing emojis and they'll be like happier with the responses if there's more emojis in them. And others, like me, I get very annoyed at the emojis and like, just tell me what I asked for and I don't want any extra fluff. And so sort of making personalized evaluation is something that's pretty important.
Okay. It's so funny. I have such like a nuance or kind of in the weeds question. You said no fluff. I explicitly told in the system message to ChatGPT, don't add any fluff. And now every response I get, it says just the facts, no fluff. At the end of the response, I'm like, no, don't even say that. But yeah, I'm still working on that prompt though.
Yeah, this is actually, it's funny because I think a lot of researchers like really like no emojis, no fluff, like give me the answer as quickly as possible. And then a lot of our users don't feel that way. Like I was talking to my parents, they love the emojis. They love it when stuff is longer and they get more information and they feel like they have more sources. So I think different people want different things from these models.
Yeah, like the preamble as well. Like, hey, a great question. It's like, no, don't say anything. Just literally give me the answer and the answer only. Heaton, are you like that? Or are you more like give me all the fluff?
Yeah, I just want it quickly.
I don't like the fluff either, but I'm probably okay with a little more conversational. So I've definitely trained it to be a little more, not trained it, but added to my system prompt to be a little more conversational, to help me with the next step, to be a little proactive. I've used those kind of words in my system prompt, and that's been helpful. I actually changed it when ChatGPT first came out. Like I tweaked the system prompt, and I'm like, scared to touch it now because it's kind of tuned. So even across models somehow, I don't know.
Yeah. So I think what you're actually saying, Hiten, is you're getting to know and like the personality of the model, kind of like what just happened with 4.0.
I tried not to make it about the model and make it in general about the responses, and that might tweak the way you think about me.
Okay, Tejal, I want to ask you about one more thing. So there was a lot of detail about the safety layer, and I know you've worked on that with real-time routing and hallucination reduction. Walk us through, like, as you're leading up to GPT-5, how you're thinking about safety, both from the routing perspective, the hallucination perspective, and then obviously like the more severe bioweapon, chemical weapon type problems.
So the safety systems team at OpenAI uses this approach called the Swiss cheese approach. And the idea of that is just have a bunch of layers of mitigations and detection systems. That way you can try to catch and cover as much surface area as possible. So starting from the very beginning of the stack, there's some pre-training data redaction we do to try to make the data that goes into the model safer. There's evaluations that are built to sort of catch behaviors throughout training. There's also specific training data for safety that's put into the model, including, safe completion, which is this new type of training that we added during GPT-5. And then after the model is launched, there's a number of monitoring pieces that we have, user verification or enforcement that we do, and then tracking actual production data and seeing what people are doing with these models. Are they using them for good? Are there problematic users? So really, the idea is to have a full stack approach from training all the way through deployment, and that helps us cover as much surface area as we can.
Okay.
Wanted to talk about the router for a second, and basically how did you folks benchmark the router, if you're able to share?
You mean the GPT-5, like switching between the models?
Yeah, switching between models and all that. Yeah.
So I didn't work too much on the router, actually. We more cared about the two underlying models and benchmarking those against their prior models. So that's what we did, the sort of pairwise.
Got it.
And, okay, and then let's talk about the different kind of sizes of models. Are there different benchmarks for the different flavors of GPT-5? Or how do you benchmark those separately, or do you? Is that a thing?
Yes. So even with the same model. So something you care about is not just the overall accuracy, for example, that you get on a benchmark, because the model could have gotten that with more or less scaffolding or different prompts. It could have gotten that with spending more or less test time compute or reasoning harder or longer. Like it could be more verbose in its answer or less verbose. And so we actually do a number of sort of controlling for those confounding variables, like in how we actually plot these evaluation results or consider them. So I would say, even though we often just report the headline metric of, hey, this model received X% on this eval, internally we care about sort of how do we normalize that across a bunch of different variables that can change based on the model. And even the same model, when sampled many times, can receive can output different answers. And so, yeah, normalizing for these things is pretty important.
Okay. And then, so overall, what are you most excited about in the benchmarking field? What is like cutting edge right now? What are you thinking about, obviously, without sharing secrets internally? But like, what's most exciting to you? Which direction, which research direction are you really like looking forward to?
I mean, internally, what I'm most excited about is my team gets to be some of the first to see these models being trained, and it feels like you're really seeing the frontier of what is possible with AI, and see that first and sort of benchmark it and look at, model outputs. And so that's personally what's really exciting to me. But in terms of other areas that I think are important, continuing to push on monitoring for alignment and improving techniques for interpretability will, I hope that gets more funding and like more third-party support and more work done there. And also just having, as more and more users play with the models, our understanding of model behavior and personality will also continue to increase.
I thought you were going to talk about the latents and that discovery, but that's a cool answer.
Those are good too.
Tejal, thank you so much for joining us today. I really appreciate it. This was awesome. You should come back again.
Thanks for having me. This is fun.
All right. See ya. Wow. Okay. Lot to think about on the benchmarking side. Yeah, it was. So I don't know if you had read those papers, Sweelancer.
I had. Yeah.
Yeah. So it's so fascinating. So it's cool to actually get to talk to the author. Okay. So we got a few things to talk about. I think let's continue on a little bit with GPT-5 just for a second. I know we've been talking about that a lot today. It is still holding the #1 spot on a lot of these benchmarks, but I think when people are thinking about benchmarks in general, they're kind of looking at them less and less, and they're more doing the vibe test. And I'm just wondering, like, do you think the leading the benchmarks has that same weight and gravity as it used to? For like a company putting it out, publishing this information as a marketing, I guess, play.
I think absolutely not. Like but it's just like everything else, right? Like we got excited about benchmark, so we start benchmarking everything, and sometimes we create some new benchmarks here and there. But you know, the other day I saw an article. This was a while ago that talked about benchmarking for accounting and finance use cases. That gets me excited. So I think we're going to see the nichification, so to speak, of these benchmarks going from math, science, physics, whatever it is. Well, physics will happen with the robotics, but all the way to real world use cases. So I think that's like what I'm actually excited to hear more about. I wish the frontier labs would do more of that, but that's kind of the one for me.
Are you using AI to help you do accounting? And before you answer that, just right before we hopped on this live stream, I loaded up all of my financials for this business into GPT-5, and I said, "Hey, create an interactive budget and prediction spreadsheet app thing." And I haven't looked at it yet, but it spent about 8 minutes on it. So I'm looking. Do you ever do anything like that?
Tons of stuff like that, whether it's accounting and finance or like P&L. I mean, all those kinds of things. And I constantly find that it has problems doing it. But when I ask it to analyze the data, it's actually, I can, if I ignore some of the hallucinations or the problems, I actually get insights that would have taken me a lot longer to get myself. Because basically it's much better than us at pattern matching. So that's what I found to be a more interesting use case than saying, hey, transform this into some other format and stuff like that, and do that, because then you have to check it. Right.
Yeah.
So
yeah, I'm wondering what's going to happen to QuickBooks. I mean, because it's like, I don't understand why I can't just type in something, a natural language prompt there, and it creates me a report. But okay, I want to talk about one more thing before we bring our next guest on. Google just released Gemma 3 270B. This is their another flavor, another size of their small open weights language model. I love it. I love all of these companies putting out open weights, hopefully also open source models, although that's not usually the case. But I really appreciate all of these local, fast, efficient models. But I think, like, actually rubber to the pavement, we're not seeing a ton of usage yet. But like, what are your thoughts overall on like using these open source or open weight models locally? Are you ever doing that?
I try to play with whatever I can get my hands on that let me run models locally on any device, whether it's like, well, two main types of devices, right? The computer or the mobile device. So I'm super bullish on this. I think what's missing and what I want to either see more of or try to do myself is actually evals and benchmarking locally on that model, on the device it's meant to be on, or the device I'm using it on, against use cases that I have, and ideally even use cases that I would normally use an API for, to see how it works locally. I think one example of this that we've seen a lot of progress in is essentially all the text to speech stuff, and being able to do that locally. I think that tech has gotten better and better and better. And then, you know, we were talking earlier about the laptops and Apple and the M chip. So makes all this possible.
Yeah, I do see, you know, Noam Brown from OpenAI said that he really sees a omni-model future. I actually asked AWS CEO about this. He believes kind of the opposite, where we're going to have a lot of niche models, and obviously we're going to need these frontier large models for some work, but there's more and more of the compute going to get pushed to edge devices. And I tend to believe that. I haven't seen it a lot in practice. I do. There's just a nice feeling about being able to download a model and run it locally and know that, hey, this is mine. I get to change it, modify it, whatever I want to do with it. But I think we're still trying to find like where those use cases are.
This actually circles all the way full circle to our browser discussion. Because and that idea that like browsers, at least my concept of browsers being commoditized, every desktop app might just have a browser built in. And then where do you go next? There's a bunch of utility of taking that website content, running it through local models instead of running it through models in the cloud. And what can we do with that? What are all the fantastic things we can do? That is kind of the question that pops up in my head.
Yeah. And then I think one other use case for me, or one other missing piece, as you were talking about, is just like really having easy web search. Because like I would say 95% of my interaction with AI is I need to know about this thing. The core intelligence of the model, the local models that we can run, even probably Gemma 3270, it's probably enough to search the web with tools, bring back that information, synthesize it for me in a really short and easy to digest answer. And so like some of the local tools have that, but I just feel like it's not as easy as just going to ChatGPT right now.
I think this is all just underexplored because we've been spending so much time on the low-hanging fruit, get an API key, run it through there, or just go log into ChatGPT. I think this is like one of the most interesting areas though, because the cost of inference is so high. And if I can do it locally and I can replace, the future I see is that at some point, these local models start replacing the inference costs of non-local models. Like they're like right now, there's a bunch of payloads, bunch of workloads happening, where you have to ping an API and they're not happening locally. Some percentage of those are going to start happening locally. I'm really excited about that because then I think we're going to see a lot of transformation from there.
Yeah, that's literally what Apple wants to do, right? They want, they're kind of framing it from a position of privacy security, which good, but I don't know if most people care about that necessarily. But the fact that they can run this stuff on device very efficiently takes the compute off of their infrastructure. The latency decreases. I just think there's a lot of reasons why it makes sense. Plus, of course, as you said, they have the crazy good silicon, custom silicon in their phones and their laptops and everything. There's no reason why they can't run at least some of the workloads locally. And I do believe that more and more compute is going to be pushed to edge devices. There's always going to be a need for large cloud-based models. But I'm excited for that workload to start shifting.
Yeah, me too.
All right, I want to bring on our next guest. This is Guy Gur-Ari from Augment Code, founder, CEO. He is a physicist turned AI builder running Augment Code. We're going to talk all about that. He was formerly at Google. Guy, come on. Hey, Guy, good to see you.
Good to see you, Matthew. How are you doing?
Doing all right. I'm excited to talk to you today. I obviously want to talk about agentic coding, but let's start from the top. Tell us what Augment Code does.
Yeah, so Augment Code builds AI assistants for software teams working on large code bases. It's the full suite. You have completions, next edit, chat, and our most used feature is currently the agent. The thing that differentiates our agent from competitors is that it works really well in large code bases. Thanks to our context engine, you can ask it to build features, fix bugs without a lot of hand-holding. It will go and do all of that for you.
Okay, dive a little bit more into the context engine. What sets it apart, what you can share, and then how did you arrive at the insights to actually build something, the context engine, which is differentiated from your competitors? Was there something about your time at Google or your prior history?
Yeah, so our thesis as a company from the beginning was that the models are going to get a lot better, but the model performance is, or their quality is only as good as the context that you give them. And especially when you're talking about large organizations, and for us, this means coding, large code bases, you have to be really good at figuring out how to get the relevant context for the task that the model is trying to accomplish, because it doesn't matter how intelligent the model is. If you're not giving it the right context, it's not going to be able to do that. And so the first hard problem that we tackled as a company is doing the research on context gathering from large code bases. I think it took us probably about a year and trying out multiple different approaches until we landed on something that works really well. And then we carried that approach through from the first feature which was completions, all the way now to agents, where of course context understanding from agents looks quite a bit different than it does from completions, but still we've maintained this high level of quality. And so I would say this thesis, as models have improved, the thesis that context is king has held true for us.
Yeah. And so was there something, I mean, actually maybe give a little bit of your history. How did you start Augment Code, and what does that origin story look like? And I know you were a physicist. Like what is that? How did you make that transition?
So I am a physicist in terms of my academic background. I spent a few years at Google working on understanding machine learning models. That's what we called them back then, before the ChatGPT boom. I think then people started calling it AI, which I think is appropriate. But we were at Google, we were trying to kind of open the black box of machine learning models, understand what makes them tick, and understand how to improve them. For me, the most interesting part of AI is solving hard reasoning tasks. At Google, we worked on trying to solve math and science questions, and we trained state-of-the-art models for doing that. But I felt that there was an opportunity, and that the time was right, especially with generative models becoming good, to build a company around the other hard reasoning task, which is coding. And so I left Google and joined my co-founder, Igor Ostrovsky, which comes from a systems engineering background, and we were incubated at Sutter Hill Ventures, and that was the thesis from the beginning. We're going to build AI coding agents for large enterprises.
Okay. And I want to talk about pricing models for a second, because there's a lot of chatter about it this week, and especially the last few weeks. When you're thinking about your pricing model, how does it align or misalign the incentives for context management? Meaning, like I think there was some pressure on some of your competitors thinking, okay, well, if you're charging X dollars per month and you get unlimited usage or some kind of high cap usage, they're incentivized to really try to reduce the context window, reduce the number of inference tokens back and forth. So how do you think about that, and how do you think about it with respect to your pricing model?
Yeah, that's something we're thinking about constantly, and for us and the whole field, this is something we're all kind of, I would say, trying to figure out, because inference is very expensive, as I think you guys talked about in the previous conversation, and we're all trying to, but the value is there, and so we're all trying to figure out how do we align our incentives with those of the users. When you price per user message, like we are doing currently, what ends up happening is that as models keep getting better, they can do more and more for every user message. They can make more tool calls, like we saw that change happening with Sonnet 3.7. I think again, to some degree with Sonnet 4, we're seeing that to some extent again with GPT-5 now. That means every user message does more for you. And we love that, right? Because it means less work on the user's part, more work on the agent's part, and you get to accomplish more with less effort. But that does mean that there is tension here between the way we price it and what you get out of it, because the value goes up, but the cost also goes up and the price does not change. So that's the basic tension that I would say exists in the current pricing structure, and is why we're continuously thinking about how to evolve it. I think the current pricing structure is very simple, it's very transparent, it has served us well so far, but we're trying to understand kind of what's next and how do we better align the structure with really the user's needs.
So you folks chose user messages, and it looks like no one else has chosen that as the value metric. So I'm really curious, and again, I know things are in flux, but I'm really curious what the rationale behind that value metric was for you folks, especially because I don't think any of the alternatives are using that at the moment.
Yeah, I think at the moment they're not using it, but this was fairly common until, I don't know, pretty recently. I can say the rationale. The rationale is, yes, on the one hand, you get this tension as models keep improving. On the other hand, there are failure modes that you get when you charge by token, let's say, or by tool call. Let's say those could be other like reasonable things to look at. The failure modes are sometimes the model starts doom looping, right? And just completely goes off the rails. And then if you just got charged for a user message, maybe that's okay. You'll send another user message. But if we're keep charging you for all those tool calls and those tool calls just go completely off the rails, that's more upsetting. So there's trade-offs here that it boil down to the fact that these models are not completely reliable yet. Sometimes you put you give it a prompt and you get magic, and sometimes you give it a prompt and you get garbage. And then if you're paying per token, that's just like more painful for you as a user. So these are the trade-offs that we're thinking about.
So it feels like you folks focus on what's more user-friendly than just token limits and credits and things like that, at least from the standpoint of you're not feeling like you're paying for all those things when they might fail or hallucinate, et cetera.
Exactly.
Okay. Matthew, I'm wondering if you want to bring up your meme and ask Guy about it since we're talking about pricing.
Yeah,
I don't
absolutely.
know. Because we got him here in the hot seat.
Yeah, while I'm pulling it up, Guy, can you just define what a user message actually means? Like, what is the definition of that so folks know how they're getting charged?
Yes, so a user message means you type your instruction into the prompt box and you hit enter or you hit send. That's one user message. And then the agent will go and start explaining its thinking and start making multiple tool calls and then do more tool calls and run some tests and so on. Those are not user messages, those are tool calls, and they are kind of all round trips that go to the language model and back. They are all language model calls, but we only charge for that. We only charge per the message that the user actually typed in and sent.
Yeah, so there is this opportunity for potentially high margin on a user message and then potentially negative margin on a user message, depending on, right. Okay, so perfect setup. Hiten, Alex, you can share my screen. Right, so like I'm sure you saw this. It was going around. We have to ask you about it. So like the meme is $100 million ARR. Like, so like all of these crazy AI companies are compressing time to growth and time to hit 100 million ARR, and then kind of let's take the mask off, and it's a huge Anthropic bill. How do you think about it? First of all, like, give me your reaction to this meme. Do you think it's funny? And then yeah, like how do you think about this as the business leader?
Yeah, very funny. I should clarify, by the way, I'm not the CEO. I'm the chief scientist, but I'm still happy to. Matt McLernan is our CEO, but I'm definitely happy to answer this. Yeah, very funny meme. Yes, inference costs are extremely expensive. We are at a time where we're trying to figure all of this out, both through pricing, both through a mix of different models. So for example, if you go to GPT-5 and you look at the pricing, those prices are lower, right? And so I'm very happy to see now that there is actually more competition in the model space, where I expect prices will go down. There's also interesting things that are happening in open source, which might bring, or open weights, I guess, which might bring prices down even further. I will say one more thing, that another development that I expect will happen is that this will take maybe a little bit longer. It's not a matter of weeks, maybe a matter of months or longer, where I expect we will move from a setup where you have one agent doing everything to a multi-agent setup. With a multi-agent setup, you have more freedom to mix and match different models. I think that's another opportunity for cost reductions. So I think so far the theme has been build products that people love and get growth. And it's quickly shifting to, oh, this stuff is really expensive. Let's think also about cost. But of course, the way we try to do it is we try to think about costs in a way that doesn't pull the rug underneath our users, so to speak. Like, we don't want to go to users and say, oh, you love our product, you've gotten used to it, great, now the price is like 2x higher or something like that. We try to completely like avoid that. But I think there are a lot of opportunities here for optimization. We've certainly spent a lot of effort internally optimizing costs. We will continue to do that. I think the trajectory is toward landing in a good place, but right now, yes, inference is just expensive.
Yeah. Okay. So I have so many follow-up questions to that. So I think first, do you think right now, most agentic coding systems allow the user to choose the model they want to use, but I feel like that's maybe going to go away in favor of just get the thing done and get it done in the best way possible. And that almost like slightly de-risks an augment code, for example, because then you're managing which part of the prompt, which part of the workflow goes towards which model. You can more accurately optimize for costs, potentially even increase quality. So do you see augment code taking on the routing more significantly in the future?
This is a bit speculative, but I do expect that will happen, especially with multi-agent systems. So maybe to get a bit technical, the reason routing is difficult right now is because if you try in the middle of a session to switch one model, let's say you decided that this model that you're currently on is stuck, like it's just not getting it, right? And you want to try a different model. Maybe you want to try a model that has more reasoning in it or something like that. Things that users will today do manually. You immediately lose all of your cached tokens. So the new model has not seen all the tokens that the existing model has seen. It has to reprocess all of those, and that's expensive. So you should have some sort of belief that you're going to get a significant bump in quality for it to be worth it. And that, I would say, is a technical limitation of the current simple system that we have, which is just a single agent doing everything. This really limits our ability to do smart routing. Basically, we can only do smart routing early on in the beginning of a session. Otherwise, the costs become really prohibitive. Once we get to a world where we have real multi-agent systems, things become a lot easier because there's a lot more flexibility on managing the context. But I would say this is currently the limitation for caching is really the limitation for achieving this vision of smart model routing, which I think is where we're headed.
Well, there's the famous, I guess, like saying about coding, right? The two hardest things in coding are caching and naming things, right? Isn't that so? Yeah, it seems like the caching problem isn't going away anytime soon. Okay, can you describe more what the multi-agent system looks like as your kind of your vision towards transferring to this multi-agent system, and how does it differ from what we're doing today?
Yeah. So I think there are different paradigms around this. The one that to me personally seems the most promising, maybe because it's the simplest and closest to things that have already been implemented, is the idea that you have an orchestrator agent who's responsible for the top level reasoning, and then it can delegate tasks to sub-agents. You see that already in products. There are alternative models, like you could imagine more decentralized models where agents, like you have kind of a swarm of agents that are talking to each other with no centralized control. I believe that's something that would be probably more complicated to implement, although maybe doable. The model where you have an orchestrator and sub-agents has advantages, again, around context management, because in this ideal world, sub-agents will take care of like the nitty-gritty details of achieving tasks, and the orchestrator can stay focused at the high level, supervising, making sure that it's all going in the right direction, resolving conflicts, and not having too much context in its context window that might distract it. It also serves the nice purpose of being the point of contact for the user, because assuming the user is still in the loop, the user probably wants to talk to a single agent and not to like 5 different agents. So it needs some kind of point of contact. So I think this model that this is the way we're thinking about it. I think this is the way most others are thinking about it, just based on the blog posts that are coming out and what you see in existing products. This seems to be, I think this will be like the first instantiation of real multi-agent systems in products. So that's at least how we're thinking about it.
And can you just clarify, when you're talking about multi-agents, are you saying they're going to be the same model, different models? Because you also mentioned the caching aspect significantly decreases costs. So yeah, just clarify, are they going to be different models, and how does that affect pricing, or your cost, I should say?
That's TBD, right? Like you guys talked about the new Gemma 3, the 270 million parameter model, right? A small model. I don't know, but I don't know how how models like that fit into the scheme of a multi-agent system. It might be task dependent, but certainly once you're able to have different agentic sessions running within one system, you have now the flexibility of using different models to accomplish different tasks. It just makes everything a lot more flexible than it is currently, where everything has to go to the same model. So these could be open source models. They could also be something like you route between Sonnet and Haiku, for example, to achieve different tasks, or GPT-5 and GPT-5 Mini or Nano. Again, this is all, I think these questions are still open. I don't know of a real production system yet that has really done this well. But I personally expect that this is going to be the next wave and the next thing that's going to give us both a bump in quality and a reduction in costs.
And one more thing on that front, really quick. Do you foresee more compute in these agentic coding systems moving towards edge devices?
That's a really interesting question. Currently, the trend is I don't see that. So one thing I don't think really is happening is the size of the models that have the most intelligence does not seem to be coming down. And so one question is, will laptop GPUs for developers become better quickly enough to be able to host some of these models? I think right now they're not. They're not big enough to host like something like a frontier model. If you have a multi-agent system, you can now imagine maybe some of these sub-agents being smaller models and running on device. So potentially, I think from a product perspective, it sounds great in theory. In practice, you now become dependent on the hardware configuration of your user. Which does complicate things significantly. So it would need to be extremely meaningful, maybe for cost or for speed or for quality, for something like this to make sense. It feels a bit early to me to go there. Yeah.
Okay.
So speaking of cost and quality, curious if you have any thoughts to share on how the GPT-5 performance has been for you folks.
Yeah, GPT-5, I think very, very interesting model. It's the first model that we've used that I think is really competitive with the leader in this space, Claude. I can give some highlights. So from what we've seen, GPT-5, first of all, it's a highly intelligent model. It's a good coding agent model, which is a non-trivial statement. It's able to accomplish tasks through tool calling. It is a very thorough model, as far as we can tell. It takes its time exploring the code base and really understanding what needs to happen before it actually goes and does it. At least that's how it behaves in our system. These things do, the prompting does matter. So when I talk about the model, I mean the model, the way it behaves in Augment. It does lead to, from what I've seen, somewhat anecdotally, it leads to good results in the end. So it is like a solid agent model. On the other hand, it is slower not in like the streaming time, but slower in the amount of tool calls that it makes before it actually accomplishes the task. Some users don't mind that. Some users find it frustrating. I think it might be a matter of preference. Another thing I can say about it is that I personally really like the style of answers that it provides. I generally don't like reading walls of text that are coming out of models, but with GPT-5, I find that it has a way of giving you, the answer might be long, like maybe I'll ask it, how does this work in our code base? And it will give me an answer with code references that I actually enjoy reading and I find easy to read because it's well structured. I think they've really nailed that. I think they nailed the answer structure. We launched it. We are in the product. We are still working actively on improving. This is what happens with every model. You got to do the prompting and make sure the API calls are correct and so on and so forth. So we are still improving the model. So these are all early observations still, I would say. I think its improvement in Augment is, the quality in Augment is going to improve over the next handful of weeks.
Yeah, so you mentioned, I mean, you folks are the context sort of company in some ways around coding. So you had mentioned the alternatives. And so curious to hear how the Claude upgrade to 1 million token context, kind of what that did for you folks.
Yeah. So, we do a lot behind the scenes to essentially decouple the experience from the exact size of the context window. So when you use Augment, you never run out of context. You can have sessions that are as long as you want, the code base is as large as you want, and we do a lot of work behind the scenes to make it completely seamless. So for us, the way our system is architected, it doesn't actually matter if you have a 128K, 200K,
Really?
1 million context window. Yeah, it's all just completely dynamic.
It doesn't help you at all? Having that ecosystem, I'm sure part of managing context is compression, expiring caches, right? There's like a bunch of stuff going on in there. I would have thought, this is surprising, that just having 4x the token or the context limit would be helpful.
Yeah, to clarify, I'm not saying it's not helpful. What I'm saying is it's kind of for us, it's more of a soft limit than a hard limit. From a user perspective, it's all transparent, right? Of course, having more context means you can put more relevant information in there for the model to look at any given point. And so it can actually improve quality. And so we are currently looking into, let's say, what parameters do we need to actually change and how to make use of this extra context. But I expect that whatever we do, because of the existing strength of our solution, I expect it to be more of maybe an iterative improvement than something completely groundbreaking in terms of the end effect that users are going to see. There's also the cost aspect. I mean, those tokens that go beyond 200K cost more. And so that's another kind of significant factor in utilizing the 1 million context window. I'd say right now we're looking into it, but that's just kind of to give the high level of how we're thinking about context windows in general.
So I did want to highlight one thing you said. You folks literally have unlimited context in the product.
Effectively, yes, because it doesn't matter how large your code base is, we're going to be able to deal with it because we're able to surface the right context to the model. And it doesn't matter how long your agentic session is, you can just keep going. So effectively, your context in Augment code is unlimited. You shouldn't actually care like if GPT-5 or Sonnet have this context window or that context window. Yeah.
That was going to be my next question, just to cap this out. It's like, hey, for you folks in your tool, it doesn't matter, basically.
Yep.
Wow.
Okay, so I have one last question before we let you go, Guy. I spoke to the Klein founder, and he said he was using Claude 3.5 as his primary coding model. So what model are you using and why?
I think it's a bit early for me to say what model I'm using. It's not currently Claude and it's not GPT-5. It's a different model. Yes. but I think it's a bit early
Breaking?
to share what model that is. Yes, I think my daily driver until recently has been Sonnet 4. Sonnet 4 has been the daily driver until very recently. Before that it was 3.7. Before that it was 3.5. Moving to 3.7 definitely required some adjustment. So I can see why some users who are used to 3.5 would prefer to stay on 3.5. That makes total sense because 3.7 behaved very differently. 4 was more of an upgrade. So I would say 4 was my daily driver until fairly recently. Yeah.
Okay, so breaking, you have access to GPT-6?
No. No.
All right, Guy. Thank you so much for joining us today. Thanks for telling us about Augment Code. If you want to check out Augment Code, you can go to augmentcode.com. Also, we'll drop Guy's Twitter in the chat as well. Guy, thank you so much.
Thanks so much for having me. Thank you.
All right. Okay, yeah. I wonder what is he talking about there?
Well, there's two things, right? That context. He dropped unlimited context window and just said, "We're good." That already was interesting.
That was very surprising.
Yeah. Don't know
right,
what he's using.
Speculation. What are we seeing here? Open source, frontier.
Their own model. I don't know. You know?
Their own model, right? Could be training their own model, but we didn't. Unfortunately, didn't get that info from him. Maybe next time he'll share it. All right. Well, that's our show for this week. Hiten, thanks for co-hosting with me, buddy. Made it easier.
Thanks for having me. Yeah. Hopefully I helped.
Yeah, absolutely. If you want to check out Hiten, you can go to @HNShaw on Twitter, and then @HeatonShow on YouTube to watch the show. Really high production value videos on YouTube. I've said this to you before. Just very impressed with your YouTube work, and check them out. And thanks for joining us on Forward Future Live this week.
See you, everyone.